Hello, my name is Naomi Mnezero, and my partner is Deborah Atala. She's here. Yeah, and we are going to talk about how we performed, to explain how we performed EDA on our data sets. Yeah, so our project is about skin diagnosis. The title is contrastive adversarial learning for skin diagnosis using attention-based capsule networks for feature extraction. So we got a data set from Hugging Face, and it is here we imported it in a VS Code to start performing EDA on it. So it is a zipped folder, and it is having tests, which is having different categories of skin diseases, and these categories we have there 23. And each category or each skin disease is having images, in it. Yeah, here as you can see. So we started by importing libraries to help us in our code, and we imported OS. This is to help us interact with files and folders. Then imported NumPy. Yeah, this is also going to help us in our code. There is also imported, from PIL, we imported image, then we imported matplotlib. This is for plotting graphs and pie charts. Then there is also Steamboard. This one is going to help us have beautiful graphs, like nice looking graphs. Then there is also importing corrections. From corrections, we imported counter to help us be able to count, like know the number of images we have. Yeah, so we started by accessing the categories that we have in the train folder. This part is to help us access the data that we have, as you can see in this folder. So this is the dataset part. Then we created this. Of course, we have to be able to know the files we have, like the image data, the labels, the corrupt files, and the files that are working. So my partner is going to take you through the next step. He's going to explain the rest of the part. Thank you.
My name is Deborah Atala. I'm going to take you through the code and how the code works. So first we have to consider a dataset path on line 9, which we are going to use to access our categories, which contain the different images. So after outlining our dataset path, we are going to access the categories and put them into a list. The categories are the different skin disease folders that we have, the subfolders, and we are going to access them and store them in a list, all the 23 diseases, skin disease categories. Thereafter, we create image data, label, and graph file lists to store our images, our labels, which are the categories of skin diseases, and the corrupt files as well. And during preprocessing, we were able to resize the images to the values outlined in line 15. And then to process our images and be able to detect corrupt files, we are going to loop through each category using a for loop. And in doing so, remember our categories, they are the different skin disease subfolders. So in looping through each category, we are going to store a category path. And while we loop through each category, we also loop through each image in those categories, the different images, and also store their image path, 922. And then after gaining the category path and image path, we are going to check if we have corrupt images, and that's the line 24. If we check if an image that's looked through is ending with PNG, JPG, or JPEG, I mean, if it doesn't end with these three abbreviations, that means it's corrupted. So we are going to skip that non-image file and we go to the try and except function. So the try function works for those files that aren't corrupt. So it's going to, on line 28, it's going to open the images. And then line 29, we see the images are going to be verified. The image is verified, and then you see on line 30 that the image, after being opened, it's converted to RGB and resized with this other size on 915 and stored as IMG. And then that image data is appended. The image data is appended with the data type of NP plot. This helps to normalize the pixel values of each image. And then the labels, our labels list is appended in the category. So for the except part of this try except function, the except is going to deal with those images that have been found to be corrupt. And so they are going to, the image path of that corrupt image is going to be added to the corrupt files list that is created in the beginning. And so we can, on line 36, we can then print the number of corrupt images that have been counted from the looping through the categories to looping through each and every image in each and every category. And then moving to line 38, we have to convert our list to NumPy arrays for faster and easier working with the processing. So our image data, the list image data which stores our images, and the labels list which stores the categories of these different diseases, we convert them to NumPy arrays, faster processing. And then moving on to EDA, first we are going to work on a class distribution pie to see how our images are distributed, if they are evenly or unevenly distributed. So in running the above piece of code with this added to it, we are going to plot a figure with a figure size of 8 by 8. And then our pie, we are going to label our pie with the values from the labels list. I mean, the labels list, we are going to get key and value pairs from there. And we are going to have our counter. The counter is going to help us to count the values in each category. That is in each class of a disease. And then we are going to set our title to percentage distribution of skin conditions. And then the PLT show is going to visualize, to show us the actual outputs. And so for that, this image right here is the output of this piece of code. After we also have this line 36 being printed as corrupt images found was 0. So for the class distribution pie chart, this is our output with all the 23 skin disease subfolders. We see that they are all equally distributed with the 4.3%. And then moving on to plot our category distribution. When you run the former code with the category distribution, you want to see how the categories are distributed. This is not so different from the pie chart. This is going to output a bar chart for us where we have the X and Y values. And on the X-axis, we are going to have the number of images. And then the Y-axis, we shall have the skin condition. And then we'll have our title as distribution of images per category. This also helps us to know the number of images in each category for all the given categories. So This here is our output for plotting a category distribution. So, and you see that we have all 23 skin disease subfolders listed with the number of images. And for our data set, all subfolders contain 100 images for each of these skin diseases, which is very useful. For us. Then we can also display sample images as part of the EDA process. Displaying sample images, we are going to plot. It's about showing random images from all these 22 categories, and in doing so, wanted to see like almost each category being represented from those random named images. So we set our axis to flatten, and we are going to look through for I on line 64, for I in range 9. We are going to look through 9 images. And on doing so, we are going to do it randomly and select them randomly, considering the length of the image data from 0 to where the image data ends. Remember, image data is our list containing information on all images for each from all the different subfolders. And then we set our title, like the title of each image that's going to be shown is going to be the label, that's the class category from which it has been picked from. And then we set our axis to be off because we want clear and we don't want congested work. So we set our axis off and then give it a tight layout and continue to show the output in Jupyter Notebook, which these are the images. So we can see that we have 9 images and they're all from the random categories or labels. And for each and every time you run this part of the code, it's going to give what? It's going to give us different images from the ones we have. Let's try to do that. Highlight this to run it in interactive window. That we are getting different random images with still their label being shown with each of them. This helps us to know the types. It helps us to know that we are able to get random images from these random categories. See that these images are happening to be different from these very first ones that we had. And still, You see this part of the code that corrupt images found are still 0. So moving on to the histogram of pixel intensities. Histogram of pixel intensities helps us to know like how our data set is in terms of brightness or darkness, considering the images. So we can also plot a histogram to help us know that we have highness to this level, highness in terms of brightness, like brightness or darkness. So we as well plotted a histogram. And for the x-axis in our histogram, it's pixel intensity. We are labeling it with pixel intensity. And then the y-axis, we are labeling it with frequency and giving it a title, histogram of pixel intensity in the data set. Let me run this too and see how it goes. So this is our output for plotting of the pixel intensities. You get to see that the frequency varies. The frequency is varying, I think, because from one category to another, we have the frequency varies from 1.2 to less than 1. Then it goes back up that. Okay, summarize it all. We were able to pre-process the data by resizing the images and also normalize the pixel values, and also using NumPy to help us work with these images in a way that the computer understands the language that the computer understands. So through the code, we've been able to look through a category for each and every category we have looked through, and also been able to look through each image produced. I mean, each image that's available for the different categories. And then in doing so, we've been able to detect and see that there are no corrupt images that have been found. And we've also been able to plot a histogram of pixel intensities, review random images to see the distribution, how data is distributed. And we see that for our data set, the data for the different subfolders is evenly distributed, whereby we have 100 images for each and every category. And that will make work easier for us. And also plotting random sample images has helped us see that that data can be got from, that we can now get data from random, these random labels, the random 20 categories that we have, that we are working with. Yeah, that's the end of our presentation. Thank you.